No! No, I'm not.
Okay. Solving multi-step equations, which means you've kind of already done this yesterday. A little bit of a review, but you can't do this if you couldn't do it yesterday. So you get another chance to make it right. From here on out, you need to know what we did yesterday. Okay, so step 1, simplify. That means distribute if you have to, which you did yesterday on some of your problems. It also means what we're going to show you today, multiply by a common denominator. If you have a fraction in your problem, you want to get rid of your fractions, we multiply by common denominator. You already know how to do that. C, multiply by the power of 10. That means if you have a decimal in your problem, you want to remove all your decimals. You multiply by 10, that moves your decimal to the right 1 unit. Multiply by 100, it moves it to the right 2 units, 2 places. By 1,000, 3 places. That's if you want to get rid of it. You don't have to. Okay. D, combine like terms. So notice that combine like terms is last here. That's what we did yesterday, but we did distribution yesterday before we combined our like terms. Okay. You can pick and choose if you want to do B and C. You don't have to. All right, but you have to deal with fractions and decimals if you don't. So I'm going to give you an example of how to do all that stuff. And then 2, solve it. And that's what you did yesterday. If you had an equal sign in your problem yesterday, you combined your like terms, you did all this stuff on each side of the equal sign, and then you solved it. Okay, so it's a lot like yesterday. All right, so let's look at a few examples. Example 1. 4x minus 3 plus 2x plus 4 equals 7. Again, look at each side of the equal sign and simplify each side first before we start to solve. Everybody do that, just like yesterday. Not any different than what we did yesterday. That's why we did circles and stuff the way we did. Minus the -3 gives me a positive 4 gives you a positive 1. Well, no, you go by what the value is. Is it positive or is it negative? That's a plus. Okay. Let's go through it. That's positive 4x. That's positive 2x. That gives me 6x. I have a minus 3, or negative 3, and a positive 4. That gives me a positive 1. And I have it equals 7. That's a two-step equation from chapter 2. This is the term we're solving for. Get rid of the other term by opposite operation. Once on each side of the equal sign. Does that sound familiar? 6x equals 6. 6 is what? Yeah, 6 is attached to x by multiplication, so we divide. X equals 1. Who got that right?
I got it right.
I wrote it down after you did one.
I added this 6x plus 1 together and I got 7x.
You can't do that. You're lucky that you got the right answer. That won't work every time. There's no x with the 1. You can't put those together. Okay? You will fail the assignment if you do that.
I did it like yesterday's.
This is a problem just like yesterday.
Yeah.
Example 2. 3 times the quantity, x plus 1, quantity closed, minus 4, plus 2x equals 19. This is just like yesterday. You have distribution that you have to do first. So everybody do that. Put like terms together, then solve it.
Yeah, focus just a little bit.
Yeah, good. Again, this is just like yesterday. Close. For some reason, it didn't work because they didn't understand it. Not having notes is not very smart. Watch. Positive 3x. Positive 2x gives me 5x. A plus 3 and a minus 4. That's negative 1. Equals 19. Some of you subtracted the 1 and got 18. But to move this term, minus 1, to the other side, to add 1. 5x equals 20. Divide off the 5. X equals 4. A little over half the class. Who got it right? Yeah. A little over half the class got it right. Huh? Does that make sense? This is back to chapter 2, guys.
5 times 4 minus 1.
Circle the term you're solving for. Get rid of the other terms by adding or subtracting. Do the opposite. Divide off the coefficient. What's the problem? Turn around. Example 3. Okay, something new, but not that new. 1/4 x minus 3/8 equals 1/2. We did this back in chapter 2. I'm sorry? Oh, okay. Yearbook forms. All right. So, you can do this problem with the fractions, or do you want to get rid of the fractions?
Get rid.
Okay, and that's kind of what we're learning in this section. I want to get rid of the fractions by multiplying by a common denominator. What is a common denominator? 4, 8, 2, 8. So I'm going to multiply everything by 8.
Why?
What? I thought
Cause
8's a common denominator.
Well, I thought
Now
that
you
to
do it
get the
together.
common denominator, like, before you to multiply by 2, and then you multiply the top by 2, so it would be 8.
That's if you want to add the add or subtract your fractions together. I want to get rid of them.
Oh, okay.
Here's what happens when you do this. So I'm going to write this out the long way. So it's 8 over 1 times 1 over 4 x minus 8 over 1 times 3 over 8 equals 8 over 1
Oh
times 1 over 2. You don't have to write it out like that. I'm just showing you that it works. Okay, so the 8 and the 4 reduce diagonally by 4. Everybody agree? Anybody not understand that? Okay, this 8 over 8 reduces by 8, so those are 1s. And this 8 and the 2 reduce by 2. Okay, so notice they're all 1s at the bottom, so it's gone. So 2 times 1 is 2. x minus 1 times 3 is 3. Again, 3 over 1 is just 3. Equals 4 times 1 is 4. Now you have a new equation.
Oh my.
What?
Wow.
Well, we've already learned it. Okay, so this is the second time we've done it. So you can do the problem without this. You'll still get the same answer, but you're going to have to add and subtract fractions. Okay, so now that's the term I'm solving for. I add 3. I get 2x equals 7. Divide off the 2. X equals 7 halves, or 3 and 1 half.
Yay. Wait, you have
I think when you're done, you should change it to mixed numbers.
So
Wait.
you don't divide the 7 over 2.
No, this is your answer.
Okay, so
7 over 2 is 3 halves, 3 and 1 half. I don't want the decimal. Can't use calculators anyway, so.
wait,
Yep.
can you?
Why? I mean, like, how did, like, why did you divide that by 2? The 2x?
This is 2 times x.
Oh,
So I want x by itself with a 1, right?
Yeah.
So if I divide by 2, that's 2 over 2, which is 1.
And I forget how to change it to a mixed number.
2 goes into 7 3 times,
Oh.
with a remainder of 1. And the denominator stays the same. Yeah. Okay, so you understand why I picked 8 for multiplying?
Yeah.
Okay, the rule is when you multiply in an equation, you gotta multiply every term. That's a term, that's a term, and that's a term. So I've multiplied each of those by 8. Now, 8 over 1 times 1 over 4 is 8 over 4, which reduces to 2. Yes?
Yeah.
That's where the 2 came from. 8 times 3 is 24. 24 divided by 8 is 3. I just reduced it before that. You don't have to reduce it. Back. Okay? 8 times 1 is 8. 8 over 2 reduces to 4. I just reduced it before I multiplied it. You don't have to do it that way. You're required to be able to know how to multiply fractions. You're required to know how to reduce before you walk in here. Example 4. Five over 6 equals x over 2 minus 3, minus 1/3. Anna, what's the common denominator? What are we going to multiply everything by? Everybody do it. On your own. Yep. The number in front of you. Come on, work it out. You're going to have to do it on your own. You might as well try it right now. 6 times 5 is 30. 30 divided by 6 is what? You don't have to do it that way. You can reduce it diagonally. You don't know how to multiply fractions?
Oh, I do.
Well, okay, so what is that? What is 6 times 5, 6? It's 5.
Okay.
Okay, what's the problem? So that's 5. What's this? 6x over 2. What's 6x over 2? 6x divided by 2. What's this? 6 over 3, which is? Okay, what's the problem, guys?
I got it now.
Okay, solve it. Finish it.
So that's how you did the other one, you did like this. Times one.
No, I reduced them diagonally before I did it. I just did it both ways here, so you, whatever way makes you happy. Okay? You got it right. Awesome.
Oh, wait, no. How did you do the 7? Oh, I see. Never mind.
All right. Something else. Decimals. 0.2x plus 0.56 equals 0.3. How many decimal places maximum is up here?
2.
This one has 1, this has 2, and this one has 1.
Oh.
So 2 is the maximum.
Yeah.
I don't want to deal with the decimals. You can solve this exactly the way it is. You can solve this one exactly the way it is. You don't have to get rid of the fractions. You can add and subtract fractions. You all know how to do that. You can add and subtract your decimals. That's fine. You'll get the same answer. But if you want to get rid of your decimals, and it's a skill you're supposed to know how to do, multiply by power 10. If I multiply by 10, this becomes 2x. The decimal point moves to the right one. But this one only moves to the right one if I do that. I want to get rid of all of it. So I want to multiply everything by 100. That'll move this one 2 places to the right. It'll move all of these 2 places to the right. So this becomes 20x. Yes?
I got a question about the fractions.
Okay.
If your denominator is already the same, would you just use that as your common denominator?
If all your denominators are the same?
Yeah.
Yeah.
Okay.
Okay. This one becomes 56. What's this one become?
30.
2 places to the right. Be 30. Now everybody solve that. Yeah, so no calculators. I want fractions as your answer.
Yeah.
I want to get x by itself, so I'm going to get rid of this term. What?
I thought you don't know how to change that.
I'm moving this term. To move terms across an equal sign, this is what we learned in chapter 2. To move a term, if I move the 20x, Let's say I want to move the 20x to the right side of the equal sign. That's a positive 20x. To move it, I got to subtract it. But I don't want to move it. I want to move the 56, the positive 56. So to move it, I subtract it. Okay? Your assignment. Page 306, 1 to 30 all.